my name on the list here. I was only added to the list. So surprise package for you just before your coffee break. So I'm a program manager at Tyndall. I look after what we call the ICT for energy efficiency agenda, liaising with industry, trying to understand how can we help industry use ICT technology, information and communications technology, to help us improve energy efficiency and sustainability, particularly in commercial buildings, microgrids, factories, also in domestic premises. So I've got a couple of slides here just for about 10 minutes just to give an idea as to the kind of things that we're doing that I believe are relevant for the sustainability and the energy efficiency agenda, particularly in factories and in commercial buildings. So just a brief introduction to Tyndall for those who are not familiar with us. This is kind of Tyndall by numbers. We have over 460 researchers, engineers and support staff, of which approximately 120 would be graduate students. We have over 200 million euros of infrastructure investment, so we have flexible fab, we have all sorts of laboratories where both academic and industry partners can come and use our facilities and whereby we use these for our own experiments. We have over 200 industry partners, all the way from startups and SMEs up to the big multinational names that you're all familiar with. Over 85% of our income comes from competitive funding. We don't get a big grant from the government. We have to go out and we have to get industry contracts, or we have to get contracts from Enterprise Ireland, from Science Foundation Ireland, or from the European Commission. We have done over, for those who are familiar with EU funding, in the last round of funding, which was called FP7, it's now being replaced by Horizon 2020. We were one of the most successful institutes in the country and indeed in Europe, being involved in over 90 EU FP7 projects, and our annual income is approximately 32 million euros per annum. We also have over 200 publications on an annual basis. So then Tyndall breaks down into primarily two areas. The first area we call micro and nano electronics. This effectively kind of goes with our tagline, from atoms to systems. We have people developing new materials, we have people developing new devices, we have people developing new systems. Some of these are at the micro level, so microelectronics. We're also doing nanotechnology as well, manipulating at the nanometer level materials and devices so that we can enhance their performance. A notable example would be, for example, materials which are hydrophilic, that if you pour water on these devices, the water just runs directly off them, so they're completely immune to water. The other main group we have in Tyndall is what we call our photonics group. So this is doing things like using things like lasers and photoelectronics for doing applications primarily in the communication space. For example, we have the world's fastest fibre to the home link between Cork City and West Cork, which is sponsored by British Telecom. So we're in the terabytes per second, not the gigabytes. And we also do a lot of work with medical device companies, giving them aids to help them, for example, for inserting stents, measuring things like blood pressure, measuring blood flow, measuring the well-being of the organs around the devices where these stents are being inserted. And just to give you a flavour for the kind of the wealth of the companies that we deal with, you can see lots of familiar names here, and lots of indigenous Irish companies here as well. We have everybody from the analog devices, the HPs, the Intels, all the way down to the Indicos and the cells and the EI electronics. So a very, very broad range of manufacturing industry partners. We've also been involved in the strategic agenda. We have over, as I said, 200 industry partners worldwide, and we have been strategically involved in trying to attract people to come in and set up in Ireland. So we're involved in FDI, foreign direct investment, through people like Enterprise Ireland and through the IDEA. And we also have a number of our people cross-trained so that they understand and they can talk about the technologies that we're developing. So I guess really Tyndall is the largest ICT research centre in Ireland, and it's really all about developing ICT for a smarter future, and that kind of breaks down into four main application areas. We have the healthcare environment, we've got communications, and the two ones that I guess are most notable for today's audience will be energy, what we call ICT for energy efficiency, and also then we would be looking at, we would cluster together food, agriculture, marine and the environment, so we're trying to make sustainable economy here as well. And when you look at some of the statistics, the Irish manufacturing sector, you'll see that you can see the second one there from the top, food, and the fourth or fifth one down, which is chemical products, and the one after that, I'm sorry the writing is a bit small, is pharmaceutical products. So you can, and then the one fourth from the bottom is electronics. So you can see there between those 3 or 4 sectors, quite a sizable amount of our revenue comes from these manufacturing sectors. And if you look at this then, if you break this down by percentage, just over the last 12 months, you can see there that you can see the top one there is food, the second one is chemical products, the third one is pharmaceutical, and fourth one is electronics. And I imagine, for example, medical devices will be loosely embedded under pharmaceutical. You can see a huge part of the revenue that we get from manufacturing from Irish companies or Irish-based companies comes from these 4 sectors. So we do have quite a lot of clients in this area. So the question then is, what can ICT do for us in these areas? And you've got a list there on your slide of the kind of things that we believe we can do to help people. We can help people using things like sensors. We can track the movement of parts and pallets and so on in a production line. We can monitor the quality of both the environment and of the products themselves. We can also look at things like temperature profiles, pressure profiles, airflow profiles within the factory environment itself. We can, of course, collect data. We can support the integration of renewables. So if a factory wants to try and install some PV or some solar, we can help them put an infrastructure in place so we can do this in a smart way. We can help people optimize their energy use and also the use of other consumables and other materials. This will very much tie in with the presentation we've just seen from Morgan. We can also help with reliability, and again, this is something that Morgan just mentioned in his previous presentation. We can help with things like predictive and preventive maintenance by censoring equipment and infrastructure determined under anomalies. And also we can help with both the real-time operation and the planning operation, both between the manufacturing side and also with the ecosystem, the suppliers, the customers, the transportation systems. So I guess this slide in a nutshell kind of covers the main core area that I work on in Tyndall. It's really about using technologies such as WSN, wireless sensor networks, to help people measure the performance of equipment and their environment, doing things like having location or context awareness. So for example, if you have a cold day, is there an opportunity to defer turning on of your heating system and save some energy efficiency, or if it's particularly sunny days, an opportunity to dim the lights. We also, from sports and medical applications, can do things like movement and gait monitoring. And one of the key technologies that I myself am involved in is what we call energy harvesting. So this is energy harvesting at kind of the microwatt, the milliwatt level. This is about replacing batteries. It's not about putting solar panels on your roof to power your factory, although we can put the ICT infrastructure to help you optimize this as well. And the reason why we believe these technologies are that they are critical for helping people monitor their assets. We can help also monitor devices, and also we can help monitor people using this ICT infrastructure, and we can help with the energy and resource efficiency in both commercial buildings and factories. And 2 of the key technologies there will be energy harvesting. This is using ambient energy such as indoor solar, vibrations, thermoelectric generators, so that we can eliminate the need for replacing batteries and sensors. This is one of the biggest impediments for the widespread adoption of wireless sensors, having to go around and change batteries in hundreds, if not thousands of devices. So if we can find ways of making these devices have power, we can certainly accelerate the adoption of wireless sensors in factories, and we can help them improve their energy efficiency and sustainability. And then one of the, subsets of this will be condition monitoring. And again, this is mentioned by Morgan from Mitsubishi in the previous presentation. We can use these sensors to determine when is equipment or infrastructure behaving anomalously. Is somebody tampering with your equipment? Is it suddenly using a lot more power than it used under the same operating conditions yesterday or last week or last year, and so on? So we can identify opportunities for improvement in the efficiency of this equipment, and also we can do things like predictive and preventive maintenance. This gives you an idea of the kind of applications that we serve. In the box in the bottom, you can see the kind of hardware that we typically develop. we're developing sensors, and then we're doing the processing and the communications of these sensors into various systems like HVAC systems, factory automation systems, and we're doing some actuation control, be it at the commercial building level, whether it's the smart city level, whether we're helping people optimize their factory, or whether we're optimizing the integration of renewables. And just to give you a flavour for kind of the diversity of the kind of hardware that we develop, what you see here is a composite picture of various hardware platforms that we've developed. This is a mixture of wireless sensors, which have multiple sensors embedded, and also actuators, so we can do things like optimization of heating and refrigeration systems, detecting of flow of products within the factory. The part in orange that you see there is a self-powered device. The solar panel that you see there is half the size of a credit card, and that solar panel, using just indoor light 8 hours per day, is enough to power that sensor indefinitely. And as you can see there, with these platforms, we've got a composite of sensors. We can measure things like temperature, light, humidity, pressure, occupancy, airflow. We can interface with electricity, gas and water meters. Also sensors which are checking for carbon monoxide, carbon dioxide levels. And we can do actuation and control. And then we can also do things like condition monitoring. We can detect whether your solar panel or your heat pump or your machine or your generator is operating efficiently and reliably, whether there's a need for predictive or preventative maintenance. So this is all about improving the reliability and improving the efficiency of the equipment and the infrastructure. In some cases we go and use our own platforms. In other cases people prefer we use off-the-shelf commercially available platforms, and we're happy to do this for not just hardware developers but also system. Just to give an example of a practical use case, this is one of the European FP7 projects that we did. It's called Mosaicusis. What you see on the left there is what we developed. This is a hardware platform. This hardware platform effectively eliminated the need for batteries for the device you see on the right, which was developed by the consortium. That's the list of companies on the bottom of the screen there, which included one Irish SME called Energy Demand Management. So the whole idea here is that we would use things like temperature gradients, vibrations, indoor light to power these sensors, and we could do what we call acoustic emissions analysis on equipment and infrastructure. In this case, what we were doing was monitoring compressors in a cold room. The whole idea here is that this is also easy to retrofit and is much more cost effective than traditional solutions. This shows you how this hardware was installed in the particular application. This was installed in a cold store in Littleton, County Cork. We put vibration and thermoelectric sensors into the cold room where the compressor is generating the cold air, and then also in the warehouses themselves, where we have different rooms at different temperatures, we use our indoor light, indoor solar energy harvesting solution. So all of the sensors in all of those rooms need no batteries. They're all powered by either Tyndall technology or commercially available. So in this case, we're able to generate over 2 milliwatts of energy based on the ambient energies that we're looking at. So again, this is all about feeding temperature information back to the compressor so we can reduce the stress and can optimize energy efficiency and also do predictable runs. Finally, just an example then of other things that we do beyond hardware. We also develop things like simulation tools. And for example, I mentioned wireless sensors earlier. One of the other big impediments of wireless sensors is people don't know whether they're going to be energy harvesting compatible, where is the best place to put the sensors, how long is the battery going to last, and so on. So we can use these wireless sensors to do all of this sensing and optimization, but we do need tools then to help us figure out can we actually design an energy harvesting set of components. Will it actually work in the real life environment that you've actually This is an example of something that we did in collaboration with CIT in Cork. We developed a simulation tool, and what you see there is a series of icons. We can select the various pieces of hardware. On the left hand side you see the wireless sensors, so we have a drop down menu where we can select some parts. We can then develop a power management layer which converts the ambient energy into a useful energy. We can do either thermoelectric or solar energy, so in this case it's solar energy, so we can just plug in the size of the solar panel cell. SC is supercapacitor, so we can just decide on the storage device we use, and we can put in the number of hours that we have each day, and then we can actually do a simulation. So what you see there in the graph, the blue and the red lines is the capacitor charging and discharging. And once we stay below the red line there, we have adequate charge to continually power the wireless sensor. And as you can see in this case, there was very good correlation between the predicted result and the actual result. That's the red and the blue lines. What you see there in green is the actual lights going on and off, so we can actually use the sensors to determine when the light is going on. So we believe this is a very useful tool for people. We can have people without any expertise to select all of these components, and we can help them with the placement of these as well, to ensure that these are going to operate indefinitely and reliably in a given system. And with 2 seconds to go, that concludes my presentation.
Questions, Mike?
Scalability is a big problem. I guess there's a few problems there. One is that everybody's situation is unique, so what we're working on one department will not work on another department, which is why I showed the simulation to them. People won't have the expertise to know how big will my solar panel be, what size storage device will be, what's going to be the energy profile of wireless sensors. That wireless sensors power profile varies enormously depending on how often you turn on and off the sensors, the types of sensors that you use, and so on. So you need a bit of expertise to figure out how much energy do I need at a given hour on a given day, and then how much energy is actually available to you, and how do you make sure you always have more energy available to you than you actually need. And one of the big problems is that it's sporadic, so it's not as if that the energy is always there for you, so you have to kind of store the energy efficiently when it's available, and then make sure there's adequate energy there for you then, when, for example, the lights are off or the temperature is raised.
I saw something recently where the NHS had developed a live dashboard for their emergency department, and they could see, what resources were there, what nurses were also patients, and it was live, and they tracked it around the hospital. It's only in some trusts, but it's other people monitoring devices. How inexpensive would they be? Do you see something like that being able to be integrated with a dashboard like that, so you can see live? Maybe they're tracking it by just asking, doing a database, maybe with their monitoring devices and could integrate seamlessly.
Yeah, I think if you were to ask me what are the two biggest application areas for wireless sensors, I would say energy efficiency in buildings and kind of e-health wearable applications, because factories and hospitals or even the home where people want to recuperate at home, these are the biggest application areas for these wireless sensors. So whether it's in the hospital or whether it's your mother or your father coming home from hospital, you want the assurance that he or she got up this morning, went down the stairs, plugged in the kettle, is moving around the house and so on. You can gather all this information using sensors. The trick really is to keep it as simple as possible. Capture the data, use some sort of a wireless protocol to get the information to a database, which will then visualize the data. Yeah, so the whole idea, it's like a light bulb. You try and use as little energy as possible to get the information to some sort of a database, wirelessly or wired, so that you can do the visualization process. But yeah, there's a big demand out there for real-time data, whether it's in the factory or whether it's in the hospital or the school or something, monitoring real-time what's happening.